Okay, we are on page 231 in your digits book or on a scratch piece of paper. So here's the formula, and you might be thinking that looks really familiar, so familiar that that's not the formula for volume of a cone. This is the formula for volume of a cylinder. But the cool thing about the cone is all you do is take the cylinder volume and you divide it by 3. So this is going to be kind of a shorter video because it's essentially the same thing as doing volume of a cylinder, just one more step, you just divide it by 3. And I wanted to prove to you why that is. So we're going to watch a 1-minute video over here on YouTube.
In this video, we'll demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height. The cylinder is filled exactly with 3 full cones of water. The volume of the cone is 1/3 of the volume of the cylinder.
So you could think of it both ways. It's the cone is 1/3 of the cylinder, or you take the cylinder and you divide it by 3 and you get a cone. So we're going to start off next page, find the approximate volume of the cone in terms of pi. So here comes this in terms of pi again. So you might want to like box that up. This means something different. Now this is an exact volume of a cone, and that pi symbol is going to be in your answer. So let's recall what our formula is. Volume equals pi r squared h divided by 3. Let's figure out what our height and our radius is. So here's our radius right here. It's 5 centimeters. Our height here is 10, so you could label that if you wanted. And now I'm going to substitute these values in. So instead of r, I'm going to be writing 5, and instead of my h, I'm going to be writing 10. So here, volume equals pi, stays pi, r squared times h, and then remember, it's just like cylinder, except you divide it by 3. So the cool thing about this is you can do all of this computation in your calculator. Just forget that the pi is even there. So if you did 5 squared, 25, times 10, 250, and divided that by 3, you're going to get 8.3 repeating. That's what this little bar means. But don't forget that pi has to go into your answer. So go ahead and add the pi symbol. And remember that we are talking about volume, so centimeters cubed is your final answer. What happens to the volume of a cone when you double the radius? So if you recall from the previous answer, the radius was 5. So we're going to double the radius to be 10, and the height's going to stay the same. So let's go ahead and look at our formula here. So our volume is pi. Let's keep it in terms of pi. 10 squared, so instead of 5 squared here, we're going to make it 10 squared. The height stays the same, and we're going to divide it by 3. So now when I type this into my calculator, I get 333.3 repeating. And remember, we wanted to do this in terms of pi. So we're going to do pi centimeters cubed. And you might be thinking, well, how does that compare to the previous answer of 83.3 repeating? It is actually quadrupled. So if you compare it to this, if you divide 333.3 divided by 83.3, you're going to get 4. What does this mean for your homework assignment? Well, when you double the radius, your volume quadruples. So you might want to write this down. When you double the radius, your volume is going to quadruple. And remember with cylinders, it didn't quadruple. It would double or triple, something like that. Okay, I believe this is the last one. So we're on page 323, short video today. It says find the volume of sand in the bottom of an hourglass to the nearest cubic inch. That hint right there, to the nearest cubic inch, that tells us, hey, you're going to get a decimal answer. We also want to point out we're using 3.14 for pi this time. So let's recall our formula. We have V equals pi r squared h, so it's the same as cylinder except we divide it by 3. In this case, my r is 3.25, my h is 7.75. So I'm going to input that into my formula. So now pi is 3.14, and I even color coded it for you. The radius is blue over there in the problem, so I made the radius blue here. Forgot to square it. Now we're back. And then the height is 7.75 and red, so I made it red here. So again, I'm going to just put this whole thing into my calculator. I can even divide it by 3, and it's really great because the Google calculator knows order of operations. And after I do that, I'm going to get, if I just did the top, I get 257.03 divided by 3. And my final answer, rounded to the nearest cubic inch. So remember that I probably got a decimal here, 86 point something, but it needs to be rounded to the nearest whole number. So this is now 86 inches cubed. If you go to page 324, you'll see 3 cones here, and it says number the cones from 1 to 3 in order from least to greatest volume. So what I'm going to do is, just to give you guys some more practice, I'm actually going to work each of these out, their volume. I'm not going to try to guess and check based on their picture which one has the bigger volume and which one doesn't. So I would encourage you to pause right here and you try to do the same, just for some more practice. Get the volume of this one, get the volume of this one, get the volume of this one, and then we can order them from 1 to 3. So pause now and give it a try. Okay, so this looks like a lot, but we're going to take it piece by piece. So this one here, I put right here, so my radius was 5, my height was 5, and I got for my total volume 130.8 centimeters cubed. And I just decided to round to the nearest tenth. It doesn't tell me to do that because remember, this is not what the problem is asking me to do. So we're going to switch to the second one. My radius was 3, put here. My height is 9, put here. I put it in my formula and I got 84.8 centimeters cubed. I think it was 84.78. So again, when you're rounding to the nearest tenth, this 7 jumped up to 8. Okay, and my next one, I got, my radius is 7. So I put that there. My height is 2. Put that there. I typed this whole thing into the calculator on my phone. And I got 102.6 centimeters cubed. And again, I think this number here was 5, but it jumped up to 6 because of its next door neighbor. So then I filled it in over here. Since my first one had the largest volume, it got the number 3. My second one, which kind of fooled me, had the smallest volume. I would have thought that this last one did, but it was this one. And then the third one here had the middle volume. So this should have gone 3, 1, 2. But I hope you guys decided to do some of these volume problems over off to the side for more practice. Please email me if you have any questions. Good luck on the assignment.